Our next speaker, we're moving on to our next topic, looking at the effect of management and land use on bacterial concentrations in loading. A very interesting study came out recently from Dr. Darren Harmel, Dr. Karthikeyan, Dr. Gentry, and Dr. Srinivasan regarding the effects of ag management and land use and watershed scale on E. coli concentrations. And I thought it'd be a good discussion topic for us today. So Dr. Gentry's here to present this.
Howdy. Howdy. One of the benefits of getting work for A&M is having an excuse to use howdy. Sorry about that. Like Kevin mentioned, I'm going to briefly touch on some of the results of the project, primarily Dr. Harmel initiated, and several of us also helping out, looking at the effects of ag management, land use, and watershed scale on E. coli levels and runoff. So we looked at 3 different scales and different watershed uses across these scales. The first being field, second being small watershed, and third being river basin. I'll give you more details about these over the next few slides. In the field, in terms of land uses, we looked at graze pasture, cultivated, and then a combination of cultivated graze field. In small watershed, we looked at a mixed rural watershed, and then another watershed that was also mixed rural that had more direct and potential inputs. So it also had a wastewater treatment plant, some dairies, some CAFOs. So even though both of them probably have some human impacts, we consider the first one to be less human impact or just less direct impacted. The second would be more of a direct human or anthropogenic impact. And then finally the river basin that consisted of all these different sites. Let's look at it graphically. We're all in central Texas in the Leon River Basin. Minnesota's on the Leon River for the river scale, and then in terms of the small watersheds, there were 2 creeks, Presley Creek and then Mustang Creek. Presley Creek was the one that was more human impact at the wastewater treatment plant and CAFOs, and then Mustang Creek, and then the field scale sites that were embedded within the Mustang Creek watershed. Just a few more details so you can see the sites, more characteristics of this. We had the 6 field scale sites, grazed pasture, cultivated, and a combination of cultivated and grazed pasture. In terms of scale, these were smaller scales, somewhere around a half or 1 hectare, except for the combination site that was 18 hectares. Then the small watershed, again, was a mixed rural, less impacted, and then the Presley Creek that was more impacted with areas in the wastewater treatment plant. And finally, the Leon River Basin. Point out, in Mustang Creek, we had 2 sampling sites, 3 on Presley Creek, and then 2 on Leon River. In terms of sampling analysis, we pulled 2 different types of samples. From the edge of field, these were runoff-initiated samples. Set up with automated ISCO samplers, runoff event, these would be a timed event, weighted sample pull, and ran. And then for the stream samples, these would try to be pulled about every 2 weeks, and also anytime there was a runoff event, samples would be pulled from this at the same time. The sample collected over a multiple-year period, and E. coli was enumerated using the coli blue method. This is giving out the number of samples that we worked with. This slide is set up the same as the 2 slides previous in terms of sample size. The difference being we had the number of samples we pulled over a multi-year period here and analyzed. So for the field scale sites, anywhere from 11 to 16 samples runoff events were collected from each plot. A larger number from small watershed, somewhere around 100, and then a greater number at the basin site. So we're jumping into data, and the next 3 data slides will be set up in the same format as this one, where I have E. coli number and CFU per 100 mil on the y-axis, and they're all box plots. I think that several people have shown box plots already this morning, so I won't belabor that too much. But 2 things to point out that we want to look at is, 1, the mean values here in the dash. These aren't geometric means, these are arithmetic mean. For the purposes of the talk, what we run statistics on is the median values, which are the solid line, which unfortunately is broken. Focus on the solid line on the box plot, and also put in the blue as the numerical value followed by statistical significance in there. So looking at it, we have the cultivated grazed pasture, and the grazed pasture. So looking as you go left to right, for cultivated, we had a median value of 300 CFU per E. coli, 100 mils. Increased to 1060 in cultivated grazed, and up to 2465 in just the grazed pasture. Now, the little letters, if the little letters are different, it means that were statistically significant. So we had lower numbers in cultivated, and then statistically the same numbers but higher in cultivated, and cultivated grazed and grazed pasture. So saw the land use effect at the field scale, that when you had the presence of cattle, you had the grazing versus the cultivated, there were higher levels of E. coli in the runoff following rainfall. Now, when we look at the watershed scale, at first focus on just the average across each of the two watersheds, and also the standard values for comparison. On the rest of the creek, this will be the more impacted stream, the one that has the wastewater treatment plant from Capos, versus the Mustang non-impacted. Even though numbers were 245 median value of E. coli and more impacted versus 114 and less impacted, they weren't statistically different. There's, as a lot of people alluded to, a lot of variation in the concentrations of the samples, and there wasn't anything statistically significant in terms of land use at the small watershed scale. So even though we saw it at the plot scale, we tended to lose it if you go to the small watershed scale, probably to the largest extent where we go. Now, when we break down each one of these small watersheds, they're independent sampling sites for each one of these watersheds. You tend to see somewhat of a decreasing trend here. And there's a few data points that trends probably more choice of words. But one thing to point out is that RC1, 2, and 3, and MC1 and 2, these are going from the more upstream portion of the watershed to the decreasing portion of the watershed. So up to down, going left to right. Now, even though the numbers are decreasing, there's nothing statistically different. So the number not statistically different at the rest of the creek. In Mustang Creek, the downstream side was slightly lower than the upstream side. But generally, we don't see this land use effect as it went up in scale from the field scale to small watershed. Now, looking at the watershed scale effects itself on E. coli levels, and this is averaging or combining all the data from each one of these scales. At the field scale, small watershed scale, and following the river basin scale. Median values at field scale 680, you see it down to 120 at the small watershed scale, down to 30 in the river basin scale. And each one of these were statistically different. So there was a decreasing level of E. coli as the scale of the watershed increased. So to conclude, Grace fields did have higher levels of E. coli in the edge of field runoff samples than did the cultivated or combined field. However, when we go to the smaller watershed, the larger scale, there wasn't a significant difference due to land use. And finally, the E. coli levels did decrease as water scale increased. So going from edge of field, small watershed, up the river basin, E. coli levels did statistically decrease in that. And in terms of implication, is it fair or an appropriate way to have the same level of consideration for impairment across all these different scales? For something that may have a lot larger impact on surface flow or surface inputs versus something that may have a base flow inputs. And if you'd like more information, this is published in Transactions of ASAE in 2010, and this will be a citation on the slides when I post it. And if you have any questions, I'd be glad to try to address them, or feel free to contact Dr. Marlon. Questions? Comments?
On your cultivated fields, there's no people influence, correct?
No people influence?
Well, okay.
Okay, so they're potentially wildlife influence.
Right.
And something I left out in this is there were some compost amendments, dairy compost amendments embedded within it. We didn't see any effect of the compost amendment, compost being applied as a nutrient source. We didn't see any effect of that in E. coli levels. But there is definitely potential for wildlife influence over cultivated fields. And just a point of fairness, even though the graze fields were higher, we can't definitively say that's all due to cattle inputs. There's definitely going to be wildlife inputs. And if you're going from a cultivated field to a pasture setting, you may be selecting for herbivores and other types of wildlife, which makes the increase of populations and get more non-cattle inputs. Kevin may show some data from his research that shows that there can be a lot of non-cattle inputs in any type of grazing system. No. Simon's question is whether we analyzed the compost samples for E. coli levels, and no, we did not analyze it. They were composted for a long enough duration of time to expected they'd be really low, and the combination of that with the fact that we didn't see any whatsoever on increasing levels of E. coli in the runoff leads us to believe that they didn't play a big role in that. Yes?
Were there any BMPs in place?
That is a good question. I can't answer that. I'd have to get with Darren Harmel, who's set this up and his people ran the site. There could have been, but I don't know the answer to that. Sir?
How much did the discharge change as you went from the small pastures up to the river districts?
I'm not sure we can answer that, whether or not it was measured at all. We're just dealing with concentration data, so we didn't look at loading or measure volume. There definitely was some difference on that, and that was one of you look at the sampling numbers. There were cases where there wasn't water to sample, especially at the smaller scale. But in terms of how much that changed, I can't answer that.
Okay, this is a question